Welcome to another video on MATLAB Tech. In this particular tutorial, we will be looking into the concept related to bus and mux. So first, what we will do, we will try to introduce some of the practical scenario, like where we can apply this mux and bus. So we will take an analogy, and based on that we will try to derive like what is basically a mux and it is basically a bus in Simulink environment. Then we will also see what are the types of problem that it solves. We are using a tool, but we don't know what we are solving by using that tool. So that part we will consider and try to discuss on that part. Then we will try to apply it to a genuine problem. So we will try to apply it to modeling environment where we can develop and use these tools so that we can understand what these tools are doing in the Simulink environment, and we will get the details of it. At the end, we will do summarize and we will conclude on this video. Stay till the end of the video so that you will not miss all these concepts which we were going to cover. Usually in YouTube, if you find so they directly jump into the problem, explain it in very nicely, but over here we will try to visualize like how the things actually are and how we can correlate it to something which we are more familiar with. Okay, so let's get started with the same. Coming to the analogy, right? So for bus and mux, coming to the school days, so we usually have two scenarios, right? Either we go for school for studies or we go for picnic with our families, right? So when you go to school, then you wear the same type of uniform with same colors so that people can identify you that you belongs to the school, right? This represents basically a mux. So mux usually contains the same type of data type which is being transmitted over the Simulink signals, and through that you can get the signals evaluated when you do the simulation. So all the signals are of same type, like you can see the school uniform is of same type in all the batches of the school, right? Coming to the other scenario, over here you are going on a family picnic, right? So there you will not have uniform. Along with that, the ages of the people will be of different, like some of them will be around 8 years or under 8 years old, maybe somebody will be greater than 60. So there is no limit, and over here you are able to see variations, right? So not all are same, this is heterogeneous. So this is a heterogeneous set, and people will be wearing different colors of t-shirt, people will be wearing different accessories, right? So nothing is uniform in this case, but still you are being carried in a bus to go somewhere. Both the cases you are traveling, right? Traveling. So usually if you see in Simulink, right, signals travel from one place to another in this same way, right? So let's see what happens in MATLAB. So in MATLAB, there are two components majorly. First is the sender and another is the receiver. It is like talking in a telephone. One will be speaking, another will be listening, right? And in this case, what we do exchange, we exchange information or signals, right? So when you do exchange the signals, then you are exchanging the data and you are establishing the communication. There could be possibility that you may pass one signal. So this is the first case. You are just passing one signal. There could be possibility that you have a bunch of signals you want to pass it, but these signals are same. So this is the case 2 where you are passing an array of signals. So array of signal means all the signals are of same type, but you are passing it in the form of an array or a signal in arrays, like first signal this one, second signal this one, and third signal is this one, and you're passing it every timestamp these values, right? And you're passing an array. There could be one more case where your signals will be different. Maybe one signal has a data type of a double, and another signal could be have a data type of single. So these are different based on their memory allocation, but these are of different data type. So how you will take that from one place to another, right? In a Simulink environment, because data need to transfer from one place to another through these signal lines, right? So that can be done with the help of this bus signal. So bus, what it usually does is collect all the different variations or different data types of the signal, and it allocates a space which is called the signal bus, and through that it communicates to the receiver. So that way you can interpret it. And there could be two components which we discussed. One is sender, one is receiver, right? And in this case, when you want to send similar type of signals, then you can use mux. When you are sending heterogeneous signal, then you can use bus. And when you are receiving heterogeneous signal, then you can use bus selector. And when you are receiving same type of signals, then you can use demux. So basically these components are used for sending and receiving the data in the Simulink model, nothing more than that. So let's now look into the problem that we want to solve in this particular tutorial. So here you have a mass damper system, right? So basically the mass damper system, it contains multiple components. So this is basically a second order system. Second order system. Why this is called a second order system? Because it has two energy storing element. One is the spring, another is your damper. So these stores the energy and also dissipate it over time. Okay. So the main objective over here is to model this, and then by modeling this, we will generate some signals as the input, some signals as the output, and those signals we will try to plot. Okay, so you will have this spring mass damper system, and that will have a spring constant K, and you will have a damping constant B, and the applied force will be X. And suppose if you apply the force, then in that case there will be some displacement, and that is now in this case X. So based on this, we can derive this equation, which is basically called system equation. Through this equation, we can develop some model. So how this equation come into the picture? So if you apply the force balance equation, then you will have F equal to MA plus KX plus CV. Okay, CV. Okay, so basically here M represents the mass of the system, K represents the spring constant, and C represents the damping constant, or here in this case we can use it as B. Okay, and then if you want to represent in the derivative of the displacement as different terms in terms of acceleration and in terms of velocity, then we can rewrite the equation as F equal to M X double dot plus K X plus C X dot. So one dot represents derivative with respect to time one time. So double dot represents double derivative and single dot represents single derivative with respect to time. Okay. So in this case, we will rearrange the entire thing and we will try to arrange the x double dot on the left hand side, and then we will try to rearrange the equation by writing f by m minus k by m into x minus b by m into x dot. So this is x, not k, and this is the final equation that we have, which is similar to this one, the system equation. Now our main objective is to develop this model. So let's jump into the development of the model that we have in the Simulink model. Here we have created already the model and a simulator script. So the simulator script will take all the relevant parameters and give those parameters some value. We have already some parameters, which is the mass of the system, spring constant of the system, and damping constant. So here I have used C in place of B, and F is the input force. If you double click on this model, it will open like this. Okay. So here what we have done is we have applied a sinusoidal input as the force. So this is the force. And here also we have applied the sinusoidal force. So first one is the force 1 and second one is the force 2. Just to see what is the difference that is coming in between these two systems. So in one of the system, we do convert the data types because we are generating it from the plant model. So it will be all similar signals. So what in this case we done, in one case, we didn't change anything, which means all the signals are same. Okay. In the second case, what we did, we used data converter blocks and we converted the data from double to single, and from double int 16, from double to int 32. Okay, so these are multiple data types, and when you try to combine different type of data types, then it is recommended you need to use a bus. So if you double click on the mux, then you can see how many number of ports are available. So these you can select and you can connect it with these, and at the end it will become a single line, right? So if you try to see this inside a display, then you will be able to see three numbers. So if we connect the display, right? So suppose I want to connect a display and I connect it over here, and then I try to simulate the model. Then you will be able to see three outputs because this is an array, right? So these are the three outputs. And over here, if you see, if I connect the same display to over here, then simulate, okay, then I cannot because this is of different data type, right? Okay, so if I simulate again, then I will get all the relevant output. Now let's look into the model and see what is actually happening, what we have designed. So we have f divisible by m, which is the first component in our equation that we seen. And we also have this integrator block. So basically the outcome of everything that we have is the x double dot. So this is x double dot, and at this point we are just integrating it. so that we are getting here x dot, and here we are getting x, right? Again, after integrating. So by doing so, I am able to generate the x, that is the velocity over here, and here is the displacement, right? And here is the acceleration, right? So after integrating the acceleration, I will get the velocity, and after integrating the velocity, I will get the displacement. And by doing so, if I multiply relevant factors, right, k by m or c by m, so c by m is for the velocity component and k by m is for the displacement component, then I will be generating this acceleration equation. So overall, it is a closed loop, and you will be able to simulate it over and over the time, and you will get the data generated. This is representing the mass temper system model. And here you will have the input force, right? So input force is coming from outside, which is the sinusoidal one. And over here, if you see, then we have the same mass temper system. Okay, there is no difference. We are generating the same output, but we are converting in this case, and we are not converting in this case. So considering the buzz and mux present, right? So suppose you are being given a model, then you need to know sometimes like how many mux and how many bus are there and how the signals are getting communicated. So you need a clear picture. In this case, like if you navigate only, you are able to get the clear picture. But suppose if you want to do it in one panel, right? So that is the model explorer. So if you click on over here, then you will get the model explorer, and here you are able to see Simulink root, base workspace, and the MSD model that we used, right? So in this case, we are able to see the bus, right? Two buses are there. So individual buses has their individual signals, right? So through this, you will be able to see like which type of bus is doing what. And there are also mux1 and mux2, and we have all the components. So all the components you can see over here. Okay, so this is the major thing that represents the model as well. Okay, so we closed the model explorer. Now we have one more subsystem. So basically we will study the subsystem later on, but we have one more subsystem which contains some set of functionalities, right? So we have two bus in this case. So first bus is this one, which collects all the different data types like first acceleration, velocity, and displacement. And over here also acceleration, velocity and displacement, but of same data type. And these data are again been combined here in this bus, because bus can take any number of inputs. So you can see over here, this is a 3x1 array, but this is a structure, or basically we can represent it either with the form of a structure only, because structure can store multiple data types, which is a heterogeneous data type, and that is the only available functionality in C. When you do generate the C code, then you can see that. Now in this case, we will have these signals going inside the bus, and we will have these signals going inside the bus, and this will be fed into the display system or display subsystem. Here you will have this input, and here we are decoding those signals with the help of bus selector and with the help of demux, right? So first what we did, so let's check the signal flow now. So first we generated the acceleration, velocity, displacement in the form of array, which is going inside this mux. If you double click, you will get these numbers. Then you will have these which are already converted one. If you double click over here, you are able to see all these signals over here, right? So whatever the signals that are coming outside this bus signal, so those contains those values. Okay, bus signal parameters. Yeah. And then when you just double click over here, you are able to see two signals, right? Which are these signals. So unmodified plant model signal, which is the first one, which is the mux output, and then the modified plant signals, which are these values, right? These values. So you already got these inputs and what is actually going in. Now, if you double click over here and you just double click on the demux, right? You find the same nomenclature because that is the signal that we are passing inside this demux with the help of the input port, right? But over here, we have again the same structure and we need to pass this to the demux, right? Which signal will be which one. So unmodified will be the first signal. So that's what you can see, one line, but whenever you are able to see multiple lines, that is the bus signal. So what we did over here, the first signal that we selected is unmodified, and the second one, what we selected is the modified signal, right? So in this case, what happened? So I need to connect one more demux or bus selector. So here I need to connect one more bus selector to trace out these signals, right? So same signals what we have outside, right? Over here. So these are the signals that I trace back in my display setting, right? So once I have this, then I will be able to plot it over here. And again, unmodified plant model signal, which are these signals, right? So these signals are coming over here, and with the help of this demux, I'm able to decode it, right? And that way I will be able to display all these signals. So basically, what we seen over here is like we are enclosing all the signals inside one variable in internally, and we are enclosing all these inside one variable. Again, we are enclosing it in all these things in one variable, and then we are unpacking the same, right? With the help of the opposite or complementary blocks, like this is demux and this is bus selector, and we have the demux, right? So if we just simulate, because the data type is now different, right? So if you just simulate over here now, so same data type will look very smooth because there is no change in the data type, right? It is all double, and whatever the system response it should be, it is the same way, right? For the second one, which is having different data types, right? So the first one is as intact because this is the continuous variation. It can store points values, but if you see int 16, it cannot store point values. So whenever the signal hit to the point of -1, then only it got changed, right? So because of that, you're able to see this change. So whenever it is hitting this -1, then only you are able to get that output. And along with that, the same applies with the other one. So here, whenever there is a whole number change, then only the signals are getting updated, right? Because of int 32. So that is the impact that you are able to see. So this is just an example. So there is no realistic requirement that is there to solve this mass damper problem. But if you apply it to a actual problem, then you will be able to decode the application what you want to implement. So this is just an example, and yeah. So in summary, what we did see, we see the introduction to the concept, and we seen like how it can be related to school going days when we to go for school or for picnic. And then we tried like what problem these two components solve, like transmission of the data between the Simulink models or inside the Simulink model. And then we applied it to a mass damper system and tried to see how the signals are changing when I'm changing the data type and embedding it inside a bus or mux, right? uh, as we already know that bus can only take different data type, but in this case there is one more possibility is there. If you give the same type of signal to the bus, so suppose you have a bus and you give all the signals as same type, then it no need to create a structure. It usually creates a array because these all data are same. Okay. So that's why when you give same types of data type and inputs of the same dimensionality, right? So in that case, you will be developing arrays in the code that you generate. Okay. And we did all these things, and here this is the summary that we completed the loop. Yeah. In case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. We will be more than happy to clarify your doubts. Have a great day ahead. Thank you and happy learning, MATLAB.